So what are the objectives and scope for this first module? Both in this section and the next one, we will initiate the project and the course by reviewing and creating various model attributes required for the project. We will not start modeling yet, as that will come later, but in short, we will just prepare everything for the project in this and the following section. For this particular block, we will review the various parameters and functions present in fields. I will teach you how to create your own symbol fields and work with other types such as solid, image, and vectorial fields. We will also review several functions related to the creation, management, and importation of new surfaces within ArchiCAD. Remember that each lesson is structured, and feel free to pause the video or replay it as many times as you need to grasp each concept at your own pace. And keep in mind that each lesson also includes different resources ranging from links, articles, PDF document, files, and more content that I'm providing you to greatly reinforce your learning process. And without further ado, let's start with the first module. Alright, so let's start off our first module talking a little bit about which concepts and topics we're going to delve into. And for this case, we're going to start off just with the basic constructive attributes. Now, I'm going to be completely honest with you. When I recorded this module for the Spanish version of the course, the module was a little bit too long, and yeah, I compressed everything into like 3 hours, and it was a little bit heavy for the students. So for this case, I decided to divide the module into 2 different parts. In this first part, we're just going to focus on the creation of surface and also the linking and creation of the different 2D fields, something really important for the 2D representation, or in other words, we are going to focus on how we can connect the 3D representation and how we can connect the 2D representation all together, so the materials you further create in the upcoming lessons are completely real, or have the completely exact representation you are seeking. Because our end goal for the constructive attributes would be the creation of the different composites. In other words, a composite, we could say, for example, if I open up this model real quick, you'll notice that right over here we got many different layers and layers and layers and more layers of different materials. And this is quite an advantage with ArchiCAD because it gives you the opportunity to take your model to a completely new level, which would be the constructive level. Especially, for example, if you want to quantify anything, you can do so, because instead of just modeling a basic 3D model, you are actually building the project in 3D with all its materials, with all the finishes, with all the details, which is quite amazing, especially if you want to coordinate different constructive projects and different elements. You can do so, and there's many advantages of building a project in 3D. So the main focus for this section would be the goal, which is the creation of the composites and also the creation of the different complex profile. Now, the complex profile is something I already explained in the previous course titled Constructive and Strategic Modeling with ArchiCAD, where I explained in real deep detail how the complex profile works. So you can pretty much create all the materials and then simply link the different parts for your complex profile. But in order to achieve the end goal, which is the definition of the composites and complex profiles, we need to create materials. In order to create the materials, we need to define and create the surface. In order to create the surface, we need to have also the 2D representation or the different field. Yeah, it's a chained process. In short words, if I go over here and element attributes, you need to specify first of the fields, then surface, then building materials. Once you have the building materials, you jump into composites and the profile manager. So everything is linked in this order. Now, something important that I want to clarify is that it's impossible for me to tell from which country you are, whether you are based on France or Germany or Italy, Spain, Russia, or any other type of country. And each country has its own materials, its own constructive process. So adapting this to an international version or international explanation is near impossible for me. So what I'm going to do is I pretty much try to translate everything as clear as possible. For example, the different concretes with the different resistance. Or in my region, which is Mexico, we usually use a compressive strength type of acronym, or in other words, it's F, prime, and C. And then you specify the resistance for the concrete. In other countries, you might find it that the resistance is measured in megapascals. In other ones, it's measured in PSI. So depending on which country you are based on, have all the liberty to specify and create your own building materials and your own for your own project, for your own region. For this case, I'm going to simply explain everything in the same way I explained for the Spanish version, using the materials we can find in Latin America and the constructive details that we can also find in Latin America. But the same process, the same examples, the same workflow can be applied in pretty much any type of region. The only difference would be that you need to arrange everything in a different way. So feel free to, if you want to follow the course as it is, go for it. But if you want to create your own personal materials and your own personal details, feel free to do so. Alright, so before we start, one of the questions would be, okay, how can I create my own surface? Just going to provide you these textures along the lessons. But how can I create, for example, my own surface, which I want to convert into material? And not just that, but I also want it to be the 2D representation to be as precise as possible. So, for example, when we create maybe some type of cutting up type of documentation for the finishes, maybe in the floor, for the finishes maybe in the wall, or even so in the ceiling, the representation of the material is as best as possible and as precise as possible. Or in other words, when you create a ground floor which has the finishes for your different tiles, how can everything be linked so the 2D representation is completely real? So that's the question we are going to answer. Oh, maybe a little long question, but let's start with the basics. How about we just for demonstration purposes, maybe just create a basic type of slab, and let's make it 200 in width. Let's just create a basic slab maybe which is 10 meters by 10 meters over here. And if you remember, something we already covered in Basic BIM Framework with ArchiCAD, the first course, or the second one, you could apply completely custom cover fields to your slabs. You simply activate the cover field parameter over here, then select which type of fill you want to assign, maybe some type of 30 by 30 grid, and press OK. And if you notice, it's going to create some type of tiling for your slab, which can be useful for creating the cutting up documentation. But also we commented that you can, for example, adjust the position for the hatch or the fill. You can, for example, activate the cover fill orientation over here. Maybe switch it to link to fill origin, press OK. It's going to give you this type of control. You can just click over here and activate the move fill handle command, which is going to allow you, if you remember, to specify the position for your cutting up. Okay, now these are key concepts when we are going to, in a near future, create the cutting up documentation, because you want to always position the cutting up perfectly where you are going to start the finish for your project. Okay, the second question would be, okay, how can I create a custom 2D representation for this type of tile, or maybe for this type of tile? And if we go back a little bit, let's select this slab. For now, we are assigning a predefined type of fill. But if you remember, if we go to options, element attributes, and over here, you will notice that we can create, well, something you already know, which are the layers, the types of lines, and what we are interested for this case would be the fields. To sum it up in another way, the whole process that we are going to apply for these two specific models will be: first we start with defining the fields, then we define the surface. Once the surface is ready, we define the building material, and once the building materials are ready, we define the composites, and we define the different profiles. To sum it up, everything is linked, and this is the reason why it's so important to cover all the different concepts so you can create your constructive solutions as best as possible. But for now, let's jump into the fields window over here. And as per usual, you will notice that in the left part, you will get the library, which has already all the different fields predefined in the ArchiCAD template. This is where you can select which field you want maybe to delete, maybe to rename, maybe to categorize in some type of folder, or even duplicate it, or if you want to create a completely new type of field, you can simply press the new button over here. Right over here, you will notice that we have the different folders where you can organize your different fields, each in its own dedicated type of folder. But if you want to work with folders, you want to work this a little bit easier, well, in my own personal preference, I usually just activate the list view icon over here, and it's going to show pretty much every type of field linked inside ArchiCAD in a continuous manner. Now, something important to keep in mind when you create a new field, you'll notice that we have 3 different types of fields that we can create and we can assign for the 2D representation we are going to use. Okay, now this is something I'm going to cover in separate lessons in a second. So let's for now just close this window, and right over here, for example, we select any type of field. You will notice that we get all the parameters related to this 2D representation or this field. You can specify pretty much where you want to use the field. We're going to get back to this in a second. Just the patterns, the representation, but this is just the preview representation, not the real representation, which is going to be in this small box over here. You get the pattern. We can work and mess around with the pattern with many different types of parameters. We can create our own pattern, something I'm going to explain in a second. To sum it up, you get all the different parameters you can mess around with in this right part. Okay, so just take a moment, check out the main window for the fields, and in the next lesson I'm going to explain to you how you can start creating your different fields. Alright, so once you want to create the field, just press the new button over here, and you will notice that we get multiple different options. The first one would be the solid field, and if I'm completely honest with you, this is the most simple one. It's basically just one type of color. You can specify the foreground opacity, screen only pattern right over here, but as the name implies, it's just a completely solid type of color or solid type of pattern, which doesn't really make that much sense in creating another type of solid pattern. I haven't made sense out of it, but this, just keep in mind that you already got 2 types of solid fields, which would be the background, the airspace. You also got the foreground. If we scroll down a little bit, you will notice that right over here, this one is also a solid type of field. You can even, so for example, filter out the different types of fields you get over here, and you will notice that we also get 25%, 50%, 75%, which is basically just messing around with these sliders, so you have some type of transparency. Okay, if you want to create some type of transparent or something a little bit more specific, you can also, for example, create a new field. Simply duplicate the maybe 25%, name it something as let's say 35%, press OK, and simply modify this value over here so you get another type of transparency you want to use with your 2D representation. The solid field is pretty much the least interesting type of field, but let's straight away jump into the symbol field, which is the most interesting one. And let's say you want to create a specific 2D representation for this type of floor, or if you want to create a 2D representation, maybe a masonry type of block, which you want to represent in a 2D elevation view, you can also apply the same workflow, the same principle. principle. But for this case, I'm going to include these two different example textures I'm going to use for these lessons in the current lesson, so just make sure to download them and have them close by. Let's for example close this everything over here. Just going to delete this element, and let's take the texture that I'm providing you. You can take any type of texture you want. Going to take the first one, simply drag it and simply drop it. And now for the tiles, let's consider that the tiles are going to measure somewhere around 60 centimeters by 60 centimeters. Okay, so I'm just going to scale them down until we get the real scale. Don't forget, simply select your image, go over here to resize command, press OK, and let's simply press left click. You can press left click on this point and then input the real measurement, which in this case would be 600 millimeters. Okay, so in this manner we get the real measurement for this tile. Now what you have to do if you want to create a fill which is going to be the 2D representation for this material, you can use whichever type of 2D tool you want to use. I would highly recommend you go along with the line tool or simply with the arc and circle tool. Wouldn't recommend that much using the fill tool, doesn't apply. Definitely wouldn't recommend using polylines, nor splines, nor hotspots. Make sure to simply use arcs or circles and lines, so you don't have any type of trouble once you are inputting the different and creating the different symbol type of fills. So for this case, let's activate the line tool and let's simply draw maybe one basic type of tile, which would be 600 by 600 over here. Let's select this tile. Well, I'm just going to move this a little bit more over here, and let's activate the suspend group. Let's create an offset in copy. Just activate the offset all edges, then press Ctrl to create a copy. You can even press Ctrl plus Alt to create multiple copies. So the first copy is going to be at 70. Next one is going to be at 140. Press Enter. And the last one, let's consider something as 210. Okay, so it's not perfect, but the main idea is that the 2D representation works accordingly to what we are seeking. Okay, so once you have the pattern you want to use, simply select it. I would recommend, well, this is not the best recommendation, but just in case, how about we select the edit, let's go to grouping, and let's make sure that everything stays ungrouped, so everything is exploded. Now what you can do is simply select the pattern you want to use, press Ctrl C, so it's from the very beginning copied in Windows. And now let's simply go to document, options, element attributes, and let's activate the fills window over here. Now when you are creating the symbol fill, once you have created your pattern and once you have copied, simply press the new button over here and let's activate the symbol fill. So for the naming, I'm going to use the same name in the provided textures, cementine tiles number 1, something as this. Let's name it cementine tiles 1. Okay, let's press OK, and let's simply press the paste button over here. This is the first thing we want to do when we are creating the custom pattern. Just simply press the paste button. Now you can use these two buttons over here to zoom out, visualize how your pattern is going to behave, and zoom in. Okay, so if you notice over here, the pattern will simply start repeating. Right over here, use width is really important because this is where you are going to use this pattern. The first icon is basically the fill tool you get over here. I would recommend, for my own experience, to usually activate the 3 types of patterns, so we get the extra option and never vice versa. You can use this, for example, with the fill tool. You can use this when we start creating the cover fills with the slab tool. And you can use this when, for example, we create some type of section and the section is cutting and maybe you want to represent the cut elements with this type of pattern for some reason. you can also use this. Okay, for this case, we definitely want it for the cover field because this is where the pattern is going to shine. Now, when you created your pattern, you specified the availability. This is where you can start messing around with the different parameters. So you got the horizontal scale, which is the measurement of the pattern in meters. So you got the horizontal scale, which is basically if you want to scale this up, maybe distort this a little bit, you can input something as 1.5. It's going to make it, instead of 600, now it's going to have something as 900. Okay, and this one is going to be 600 millimeters. But usually, let's simply just leave it at 1, so it stays in the true scale or the real scale. You can also mess around with the rotation if you want to make this 45 degrees. Now, it wouldn't make that much sense because we also get the specific type of controls handed out inside the slab tool. Something we showed in the previous lesson and something we're going to get back in a little bit. Now, you got the possibility to mess around with the strokes, how you want to work with your definition. For example, let's input 900 in the horizontal displacement. So basically, it's going to take the pattern, okay, right over here, and the next pattern is going to be positioned at 900 millimeters. So you're gonna get this small gap of 300 millimeters. So you can mess around, for example, or also separate this a little bit, zoom out a little bit, and if you notice, you're gonna get a continuous gap of 300 millimeters or 30 centimeters. If we want everything to be more precise, let's just leave it at 600 and 600. But you can also mess around, for example, maybe offset the pattern 300 millimeters. So if you're gonna get something more interesting where one tile is going to be continuous and the other tile is going to be offset 300 millimeters, you can also, for example, offset this in the vertical direction, but this is going to get messy real quick if you offset this in two different directions. Okay, so just make sure to offset this just in one direction at a time, either way in the horizontal or vertical pattern, so you get something a little bit more interesting. For this case, I'm just going to leave this as 0. You can also activate the original arrangement and fully ignore the definitions you get over here. And lastly but not least, you get two extra options over here. Scale with plan, which is going to be the model size, or scale independent. If you activate the paper size, just note this, how everything will turn into millimeters, okay? And this is the definition that is going to apply in the layouts definition. This means that if you, for example, are creating some type of sheet, some type of layout, which is 900 by 600 millimeters, you got your floor plan over here. And let's say you got some type of room which has the representation, the slab inside with the pattern specified. Well, the pattern is going to measure whichever value you input over here. Okay, it's going to measure 6 millimeters independently to the scale you are using. For example, if you scale this to 1/75, it's also going to stay 6 millimeters. If you scale this down a little bit more to something as 1/100, the final pattern is also going to measure 6 millimeters. So if we are looking for completely a real type of representation, I wouldn't recommend the paper size parameter. I would definitely stay with the model size. So whichever value you input over here is going to matter once you start scaling down or scaling up your project. For example, if you got a room which is 1/75, then you got a room which is 1/100, and finally a room which is 1/150, something as this. The pattern is also going to scale proportionally to the project. So this is going to get a little bit less and less, and the real measurement is also going to scale down. If you activate the other parameter, this measurement will always remain constant. So this is a really important detail to keep in mind, because many of the students usually activate the paper size and then they usually don't visualize the real measurements for the tiles. So pretty much this is it for the symbol type of representation. Once you are done specifying all the different parameters, understanding how the different parameters work, well, we also need to comment how the screen-only pattern will work. This is just the preview symbol you get over here. This is not the pattern which you are going to specify over here. This is just for preview purposes. So, for example, if you can click and start messing around, hold down left click to maybe delete all the small squares we got over here, which is a little bit of tedious task, but if we delete the squares over here, you can notice that now the small preview box is completely flat. Okay, but if you want to make some type of nice preview, which is according to this pattern, well, we can do something as this. For example, hold down left click, we can create some type of internal fill. I'm just going to take a minute over here. And we can create some type of screen-only pattern as this, okay? And if you notice over here, now the preview is really nice, and we will have a clear idea of which pattern we are talking about for this type of field. So this is just an extra you can also specify. Once you are finally done with your symbol fill, let's press OK. And now what you can do is, for example, activate the fill tool. Let's specify that the category is going to be simply a drafting field, and let's search for the custom created field, which is going to be the cement tiles number 1 over here. So for example, if you draw a basic field, which can be somewhere around, let's say 9 meters by 6 meters, press enter, you will notice that now the pattern you want to use for your own custom material is going to completely automatically repeat in both of the directions. And you can also, for example, select this field. You can activate the construction method for the second type of method, press OK. And once you start specifying the cutting up for your project and the different types of documentation related to the finishes for the project, you can mess around with this option to exactly position the definition where your cutting up is going to start, maybe from this angle, and it's going to continue within this direction, so the construction worker have a clear idea of how to position and how to create the cutting up for this project. And the best part is that, of course, for example, if you model a slab which has this material with this surface, something we're going to comment in a little bit. Let's say this is the same slab, 600 by 600, and you want to include this type of representation for your slab. Let's simply go to the floor plan and section within the slab settings, activate the cover fields, and you can specify the custom created type of fill over here, which is going to be the cementine tiles. Press OK, and now it's fully included within your slab, and this is a secret to create the different types of documentation related to the finishes for the project. So having said this, take as much time as you need, check out the symbol field, make sure to create your nice representation for your cementine tiles or for your own material, and in the next lesson we are going to continue covering the functioning for the image type of field. Now, the image type of field is useful, for example, if you want to create some type of Photoshop representation using ArchiCAD, because it literally takes the image you import over here and is simply going to convert it into the field. Okay, it's the same way, for example, in AutoCAD, we got a command which is called superhatch, which simply takes an image and will repeat it continuously along a surface. Okay, so for this case, let's once again go to the definition for the fields over here, and let's create the same type of representation, cementine tiles 1, but let's make it some type of texture type of field. Okay, just going to copy the name and let's switch this to image field and press OK. So how does the image type of field works? It's not going to be available for your cut fields. simply usable with the drafting field, which is a 2D tool you got over here. And of course, you can apply this within your slabs. So you will get the same type of screen-only pattern you get over here, which you can customize to your own liking. Process which is a little bit more tedious. I'm just going to leave it as it is. And the first things first, you need to press the browse button over here to specify which texture you are going to use. So for this case, you have two options. You can use textures which are already linked within the template that ArchiCAD has. And if you notice over here, you got a bunch of different textures you can use within your fields, within your project, within your renders. But in this case, let's, for example, simply click the add button over here to import a completely custom type of field. So in my case, I'm going to navigate to the folder where I got all my different fields. And let's select the same example type of field we are using within these lessons. Just going to select this image, press the open button, and it's going to be, don't forget, everything you import is always located in the embedded library. So let's select this element, press OK, and now we have created and linked the image we want to repeat multiple times. Now keep in mind that the same rule will apply whether you want to scale this with your plan, with the model size, so the measurement will always remain true independently at which scale, or if you want to scale this down to the paper size, which will remain constant, ignoring completely the different scale you want to use for your representation. Okay, you can also specify over here which size you want for your pattern. Since I'm importing the whole image, in this case this should measure 1200 millimeters by 1200 or 1.2 meters. So in this case, let's specify we want 1200 by 1200. Or you can deactivate the original proportion or break the rules a little bit and specify this to be completely true size. Okay, so once we have created the image field, let's press OK and let's give this a small try. So in this case, I'm going to maybe cut this a little bit, maybe align the slab with the field. So let's create a basic copy of the field or the 2D field and the 3D slab over here. For this case, let's switch the type of field. Let's search for the cementite tiles textured over here. And right away, you will notice that now the image is being repeated, and the same will apply within the slab, where you can link the textured version for your custom field within your slab, which will give you this type of nice representation. Now, for example, you can, on top of the slab, model some types of walls and create your custom 2D representation for Photoshop. Well, in this case, it's still not visible as a 3D surface, something we're going to fix in the upcoming lesson once we get to the surface part. But the most important thing is that the 2D representation now is completely customized. So you can pretty much use two different methods, one which is for technical purposes and another one which is nice if you want to create some type of presentation panel or maybe some type of Photoshop representation for your project. So as always, take as much time as you need. Check out the other type of field, which would be the image type of field. And lastly but not least, you also get the duplicate option, which is quite useful if, for example, you maybe want to take basic type of tile, maybe some type of 60 by 60 tile we get over here, maybe turn this to 75 by 75, so you can pretty much select new, duplicate, and for example name this 75 centimeters by 75, press OK. You get the predefined preset over here, and now you can simply mess around with these parameters and turn this to 75 by 75. Okay, so as always, take as much time as you need. With this, we can now put an end to the fields and now continue with the other topic, which would be the 3D representation linked with the 2D representation. Alright, so having explained how the fields work within ArchiCAD, how you can create your own custom patterns, start applying them, Now the question would be, okay, how can I take this from the 2D plane to the 3D representation? And the best part would be, for example, if let's go over here. Don't forget that you can always use the middle icon over here if you want to split the screen in two parts. So let's click over here. Let's split this, leave the 3D representation in a separate window and the 2D representation in its own dedicated and separate window. Don't forget that if you are working on Mac, this option is not going to be available, but you can also find the same option if you go to the menu bar window and search for something which is unpin the windows, some option called like that. Just give it a quick try. But referring to what I was going to say, the best possibility here would be how can I match exactly the same position in 2D and also exactly the same starting point for my pattern in 3D. This is the best part, how we can link everything 2D and 3D. This is a question we are going to answer. And first things first, how about we go to options in the menu bar over here, and let's go to element attributes. Once you are done with your fields, you continue with the surface. Okay, now this is where you get different options. First things first, you will notice that this is pretty much the same as we already mentioned within the fill window, where you're gonna get different options such as creating new surface. You can duplicate them, you can rename them, or well, create new folders to organize them a little bit better. You can rename them and you can also delete them. You also get the different folders where all the different surfaces are based. And you can also, for example, activate once again the list view, explode everything and visualize everything in just a continuous manner. And in the right panel, for example, let's select any type of surface. In the right panel, you are going to get all the different parameters that will affect the 3D representation or the 3D surface. One of which, the most important one, something I'm going to explain in a little bit, would be the engine settings. This is where you have two different options, whether if you want to create some type of photorealistic visualization or you want to create some type of rendering project. You definitely want to use Cineware and Redshift type of engine, but if you are looking forward just for basic representation purposes or the real-time representation, which we are going to use for this series of lessons, you want to leave it at basic engine. And just keep in mind that the parameters are really different from the basic engine to the Cineware engine. You also get the hardware acceleration if you want to use another type of representation for your material. So take a moment, just check out the different options we get within the surface window. And in the next lesson, in more detail, I'm going to explain to you which are the difference from the basic and the rendering type of engine. Now in ArchiCAD, you got many different types of representation. One which is a real-time representation. Okay, this one we usually view, we usually orbit, everything is given us in a real-time feedback. Okay, but for example, if you right-click and activate the photo render projection, it's simply going to take the static position for the model and it's going to render out the project photorealistically speaking. Okay, so this is a render type of representation and this is a real-time representation. Now keep in mind that, for example, if we go to the 3D styles, you will notice that we can also configure a little bit more the 3D engine. By default, it's probably going to be with the hardware acceleration turned on, but if you activate the advanced settings over here, it's going to open up another window and you can also deactivate the hardware acceleration if you have some type of issue with your graphic card or want to save resources while rendering the project. You can activate this option. Okay, so just going to deactivate it for now. But the question is, okay, why did we mention this? Because if we go back to the surface in options, element attributes and surfaces over here, you'll notice that in the engine settings we get three different options. We get the hardware acceleration type of options, where these all the different parameters specified over here will directly impact the representation we get in our model. Okay, the real-time model we visualize. If you deactivate the hardware acceleration parameter within the 3D style window, you can mess around with the basic engine, which is pretty much also the same. If you notice, it's going to deactivate two parameters, and it's going to base off of what you get over here. Okay, usually we can configure a little bit the basic engine, but it's almost the same. And finally, but not least, you also get the Cineware and Redshift by Maxon type of engine, which is used specifically when you render out your project in photorealistic type of style. So for example, for this case scenario, how about we take maybe the okay, let's take carpet number 1. If you notice, the Cineware has some type of definition, and let's jump into the basic engine. And maybe how about we mess around and delete this texture, and how about we link a completely different type of texture from the ArchiCAD catalog that already has lots of images. Let's link something as brick, this type of brick. So the basic engine and the hardware acceleration engine will have one type of texture, and the rendering engine will have another type of texture. And this is one of the most common questions and one of the most common problems that I usually find within my students. They usually modify some type of parameter and then ask me why is render represented in one manner and why is the real-time model represented in another way. So if you notice, I assigned the texture, I just modified. In the real-time model, this is represented in one specific way, but if we render this in photo render projection over here, you will notice right away that now this is represented in a completely different manner. So just keep this small detail in mind. This is the reason why we have multiple engines over here. And the most important thing is that for this whole course, we are going to use just the basic engine. We usually go in depth covering all the different parameters for the rendering engine in another dedicated course where we speak a little bit about the graphical expression techniques with ArchiCAD. So as always, just take a minute, check out the different parameters for the basic engine, and now in the next lesson we can continue talking a little bit about the different parameters we get over here for the basic engine, and also how you can specify and configure in more depth your own custom representation. Alright, so once we have commented the main important points for the surface, the question remains, how can we take this 2D representation into 3D? So let's go to options and surface once again, and for this case let's create a completely new type of surface which would be named cementine tiles number 1, something as this, if I remember well. And now you're gonna get different options. You can duplicate the surface, any type of surface you want to use as your base. You can create a completely new surface from the catalog. Now this is a really useful option because as I already mentioned, ArchiCAD has a surface library which is already linked within the main library. You can pretty much search for any type of surface that is already predefined. And for example, let's say in concrete, you got many different options. You can create some type of concrete which is a little bit more white, or maybe some type of concrete which has a raw representation. Now keep in mind that pretty much this option, this is the one that we are going to use more often, especially when we start defining the different surface, the different representation. I made a quick note over here, imported from ArchiCAD surface catalog. So this means that you don't need to create the texture from zero, you just need to simply import it from the catalog. This one is created from zero, this one is already imported, and as you can notice, almost all the different surfaces we use for the building materials are simply imported within the library that ArchiCAD already has. So if you notice over here, you can pretty much import any type of surface. So for example, select this one and press OK. And as it is, almost instantly, you already have everything to configure your 3D representation for any type of material. Now you get another type of option, replace settings from catalog. If let's say you already like the name, maybe the parameters are quite decent, you just want to switch maybe the representation, well, let's press new. You can also use the replace settings from catalog and, for example, search for another type of concrete. Maybe you didn't like this representation, well, let's simply switch it to maybe this one over here. And as it is, the surface remains constant, the surface remains the same, and if you linked the 3D representation to your material, well, now everything is going to change to new definitions, okay? And if you want to create the surface from scratch, well, in this case, what we want to do is maybe duplicate some type of similar surface within ArchiCAD. For example, maybe the 60 by 60 tiles is a nice base we can take. Then name this as cementine tiles number 1, and let's simply hit OK. So now you can continue. For example, the first thing we would want to do is replace the texture linked within this material. First things first, click the remove image button over here. Okay, now the surface will be completely clean, and you can activate the other button, which would be the browse for image button over here, and simply press the add button so you can start linking your own personal texture. Okay, let's select the cementite tiles number 1, press open. Don't forget, everything will remain in the embedded library. Let's simply select it and press OK. And as simple as it is, you have created and linked your own personal texture. Now let's continue specifying the measurement, the real measurement for these tiles, since we got 4 types of tiles in this texture, and we already said that each tile will measure 60 by 60. In this case, the whole image would be 1.20 meters by 1.20. So let's make this 1200 and 1200 millimeters, or whichever unit you are using within your own project. Okay, now you can, for example, you got the sample, you can visualize the repetition for this texture. You can even customize the repetition, but since it really doesn't matter with this texture, well, it's not going to take this much effect. Maybe, for example, if we use some type of brick brown, you can mess around with the repetition over here, and this is where you can notice that it will actually take effect. But for the other texture, since it's almost the same in any given direction, it's not going to take that much effect. Okay, so let's leave it just as a basic type of position. You can also specify the rotation for your texture, make it 45 degrees, but in this case, let's leave it just at 0. So this is how you can specify your own personal texture. Just give it a try, press OK, and for example, select this slab. Let's go to the settings, and let's simply assign the texture we have created, cementine tiles number 1, just on the top surface part, and press OK. And now you can see that we get pretty much the same representation in 2D and the same representation in 3D. Alright, so far we have solved the 2D and 3D representation. Now the question is, if you apply a 3D surface, how can you optimize this so it automatically reads the surface and applies the 2D correct representation for the surface? Now there is a really nice option you get within the surface, which would be the cover fill foreground. This is an extremely useful and powerful parameter, because this means that for each 3D representation you create, you can also already link how it's going to represent in the 2D view. So for example, if you directly read this surface, it's going to automatically assign the grid 60 by 60 fill. But in this case, how about we switch this a little bit to maybe cementine tiles, symbolic representation we created earlier. So now, if you notice, everything is completely linked. Now, how can you use this option and how can you activate it? It's pretty simple. Press OK. And once you have assigned the correct surface for your for each type of element, let's make it even a little more exciting. How about we maybe assign the surface for this wall? So for example, go to the settings and override all the different surface for cementine tiles number 1. Press OK. You notice over here, well, in 3D it's represented. In 2D, well, we got the slab representation, which is assigned manually by going to the slab settings and manually specifying which cover fill we want to use, okay? But if you want to automate this as best as possible, you got this simple parameter, which is called use fill from surface. This is the best and most amazing thing because you can simply activate this parameter and it's simply going to read your 3D representation. It's going to read the 3D surface and whichever fill you got assigned for your 3D surface is going to take it into the 2D representation. So this is where you can specify to use the fill you already have assigned for your surface. If you deactivate this option, you have the manual possibility of applying whichever fill you want. If you activate this, it's going to completely read the assigned fill for your surface. For example, if we go back to surface and in the cover fill foreground, we maybe assign another type of representation. Let's say maybe some type of glazed type of tile. Press OK. You will notice that right away your representation has changed. Okay, so just keep this detail in mind. It's extremely useful and it's going to save you a few clicks when creating your constructive documentation. Now the question remains, okay, how the 2D representation will work in the case scenario for the walls. And in this case, let's create maybe a section view over here. It's going to create a section over here, completely new section. Okay, let's open up this section and let's visualize how it behaves. Now, in the sections, if we recapitulate a little bit the different parameters we already covered in basic BIM framework with ArchiCAD course, we go to the section settings or the section definitions and jump straight into the model appearance. Don't forget that you get this parameter over here, which is called surface cover fill foreground. If we activate the parameter, it's going to start reading the different surface we have applied for our model, and it's going to take the 2D representation and apply it within the section view. So this is pretty much the same thing as we already covered within the slabs, but applied in the case scenario where you have the material for a wall and you want to create some type of finish type of documentation or cutting up type of documentation within your different walls. So in short, just simply activate the surface cover fill foreground and it's going to read the representation you got within your wall, and with the slabs you activate this option within the slab parameters. So as always, take as much time as you need. Check out how you can link the 2D and 3D representation all together, and in the next lesson I'm going to explain to you how you can perfect this a little bit by specifying the correct origins, so the origins for the cutting up of the material in 3D and 2D matches in the exact same position. Now this is an extremely useful option because maybe in your model you notice something as this. You got this cutting up which is not completely exact, and maybe you want your first tile to be position complete. Okay, and the question is, okay, how can I fix this so in my 2D representation it doesn't show with the same pattern, and in my wall it doesn't show with the same pattern? And this is an extreme advantage because if you have applied the process of linking the 2D and 3D representation both in the wall and in the slab, everything will stay the same. Because, for example, if you activate the model window over here, you can simply go to document. Well, before we jump into this option, you need to specify which texture you want to align. The wall, the slab. In this case, let's select, for example, the slab. And now let's go to document, creative imaging, and align 3D texture. And over here, you will notice we got 3 different options: set origin, set direction, and simply reset the position. So this is a really specific option we get inside ArchiCAD, but an extremely powerful and useful option, especially when creating the finishes or the layout plans for our different tiles, for our different finishes. So let's activate the set origin option once again, align 3D texture, set origin. Now what you can do is simply left click anywhere you want to specify the new origin for your project, and if you notice, it's going to switch the position for your texture. And as a consequence, you will notice that right away in the 2D representation, this has been exactly updated to match always the same position you get in the 3D representation, which is completely awesome. Okay, now let's make sure that this stays in the correct position. Let's activate the slab, document, creative imaging, align 3D texture, and set origin. And let's simply left click over here. Now, as you can notice, the first tile will remain completely full. And if we go to the 2D view, you will notice that the same behavior will apply in the 2D representation. Now, the same will apply, for example, for the wall. We can select the wall, document, creative imaging, align 3D texture, and set origin. Okay, you can specify the origin to maybe be this corner over here. Okay, everything's looking good. And now if you go back to your section view, you will notice that the cutting up position for the first tile, or the layout position for the first tile, will remain exactly the same as in the 3D window. Okay, now just keep in mind that this is the best option, and in my personal experience the most efficient one, because you're just saving up so many clicks once you get into the 2D documentation part. Okay, now keep in mind that you can always, for example, select your slab, and you can also, for example, activate the cover fill orientation. Instead of being the custom distortion, maybe activate the link to fill origin, press OK, and simply mess around maybe with this small option, specify another type of origin just for the 2D representation. Whichever change you make in 2D using the option to specify the cover fill orientation you get over here, just keep in mind that the 3D position will remain the same. But in my own perspective, I rather set it to maybe link to fill origin, press OK, and reset the position to these corners. So as always, take just a minute, 2 minutes, mess around with this option, check out how everything will connect in 2D and 3D, and once you have these options clear, we can move on to the next topic. Now, before we jump into the activity, the project, I want to explain to you, I want to share with you one amazing function that is going to just save you even more clicks while working the finishes for your project. And that is going to be the Surface Painter. Now, this is a function we usually use in the rendering and visualization branch with ArchiCAD, but you can also apply it for constructive intentions. So let's simply go to the menu bar, window, palettes, and you get over here the, well, you can left click the arrow you got in the very bottom, simply search for the different options, but the one we are interested in is the Surface Painter over here. Simply activate this option and you are going to get a floating window, which you can always position wherever you want. It's going to leave it over here, and this is quite an amazing option because if you have used and you have worked with the SketchUp application, which is also a 3D modeling tool, it also has a paint bucket tool, and it's going to give you a nice list of all the materials available. So if you have used SketchUp before, I think you know exactly what's going to happen with this function, okay? Because easy as it is, you can simply, for example, select any type of surface you have created and simply click on the model, and it's going to instantly paint that part of the model with the desired surface you want for your project. And the best part, here it comes. If you notice over here, if we click the 2D window, the 2D representation will automatically update, which is completely amazing because everything stays represented exactly the same in 2D and 3D. Okay, so let's continue messing around with the surface painter. For example, let's take maybe the brick material or the brick surface over here, and let's select this finish. Let's see how it behaves in the 2D window. Just going to take this window, move it around a little bit. And if you notice, yes, the surface will remain completely linked. Now you got a few extra nice options. For example, the droplet icon you got over here, you can simply activate the droplet. Click on each surface you want to detect, and it's going to automatically select which surface is applied to this wall. Besides the droplet, you also got a nice option, the paint mode. If you activate the first option, which is the basic one, you need to left click, paint your material, then left click, paint your material, and so on. Okay, but if I press Ctrl Z and switch to the second type of mode, which is continuous painting, you can simply select any type of material and simply left click, and left click to quickly assign the correct finish. And besides that, if you notice, if you don't have anything selected, let's select, for example, this element, you'll notice that ArchiCAD in this other window will automatically give you a list of the surfaces you got over here. And you have another nice way of painting your elements, because, for example, if you select just the material over here, simply left click, for example, this surface, you'll notice that it's going to also paint it without having to recur to clicking on the modules, which is quite a nice option we got over here. But even nicer because, for example, you can create multiple copies of this element, and let's say you want to select and paint everything, for example, these 4 elements, these 4 slabs in just one go. How can you do so? First things first, you can simply select all the slabs, just go to design, for example, activate the slab tool, Ctrl A to select all the slabs, and right away you can notice you can apply the same trick, simply select your desired material, let's say this concrete over here, and let's apply it to this material, and everything is going to be painted within just one go. Or you can apply it to this material and everything will change in just one go. Or for example, selecting the whole project in just one go, and it's going to give you the list of the assigned surface you got over here, and you can simply assign the new surface, override it in a much faster and simpler way. So as always, take just a minute, give this option a try, check it out. It's quite a nice and practical function we got within ArchiCAD. And in the next lesson, now we can continue by starting the project we are going to work along the whole course. Alright, so once we have covered the different concepts related to the creation of fields, the linking, the surface, let's put everything now to the practice by starting off everything required for the project. For this case, just for this table, which are the different surface. Now, in this present lesson, I'm also going to include just 3 specific surfaces we might want to use for some materials, which are these type of tiles we are going to use on the floors, the red descent layer, especially for the slab on the roof, and then also the solid base brick. In Spanish it's called solera, but it's just a base brick you can use also to waterproof your slab. Okay, so just 3 different textures, make sure to download them. And for this case, I'm just going to explain how about we do the first 3 step by step. I'm going to explain everything from scratch, and then I'll simply register the rest of the surfaces in the rest of the lesson. Okay, so let's start off with the first type of surface, which would be the brick. For this case, the brick is going to be linked once we create the concrete hollow block 15 by 20 by 40 centimeters, and we are going to link this surface. So in this case, as you can see in parentheses right over here, I made sure to create this node. You can simply import it from the ArchiCAD surface catalog. So in this case, let's delete everything we have so far in 3D, so we just leave the project as it is. And now let's go to Options, Element Attributes. Let's go over here to Surfaces. And now what you can do is simply left click on the new button over here. Let's press click on the new from catalog over here, and right over here you can start searching for the specific surface we require for the project, which would be brick 22. So let's simply search for the surface, which is this one over here, brick 22, and well, the version of ArchiCAD you currently have. To make things a little bit easier in the upcoming lessons, I'm just going to switch it just a little bit, the name. I'm going to delete the version of ArchiCAD, and I'm going to add the nomenclature, which is just 00 and then brick 22. The reason is simple. I just want the surfaces that I create to appear at the very top of the whole list of the surface. So in this manner, we'll need to search for the different surface in the whole soup of surface we got inside ArchiCAD, but we already know that all the created surfaces that we have done so far will always appear on the very top of our list, okay? Now, as you can see, you don't really need to create anything else because the surface already has correct 2D representation, which we don't really need, and it has a decent texture we also can use for the constructive material. Okay, now for the next one, which is city line light gray, this one is an external texture. So for this case, well, if I remember, city line light gray has a tile which measures 60 centimeters by 60 centimeters. So just keep this small detail in mind, which is this surface over here. Let's go back to ArchiCAD. Let's press the new button. I'm going to add the nomenclature 00, so always it appears always on the very top. And let's name this city line light gray, something like this. We can even duplicate the surface, so it saves us a few clicks. For example, maybe duplicate it, base it off from the ceiling tile, which is 60 by 60, and then press Ctrl V and simply rename the duplicated surface. Okay, let's press OK. We got the tiles. If you notice over here, we don't really need to do anything else for the 2D representation over here. And now what we have to do is simply replace the texture. So first things first, let's remove the texture so everything stays reset. And now let's click the browse for image over here. Let's add the texture and let's add the city line light gray texture over here. We simply open this up. Now it's imported, and let's press left click. Now if you notice over here, since this is 60 by 60, just keep in mind that the first tile would be 60 and 60 over here. So we need to make sure that the value we input over here will consider the real scale we got for the whole image. So that would be 1, 2, 3, 4, 5. 5 tiles by 60. That would give us a measurement of 3 meters, or in other words 3000 millimeters, if I'm in the correct. And now with this we can say that the tile is pretty much done. We can simply double check in the upcoming lessons. We can simply measure the tile. If it measures 60 centimeters, then we're in the correct. And the 2D representation is set. Now let's move on to the next example, which would be the raw dark gray stucco, which is also imported from the ArchiCAD catalog. So for this case, let's press the new button, new from catalog, and you can simply even search for the surface right over here. It's going to give you the list of all the stuccos you have available within the library. And the one we want to use is stucco dark gray roof. This one over here. Let's simply delete the version. Let's open up 00 over here. And now we are pretty much done. Let's press OK. And now, well, the background, if you want to change the 2D representation, we might even adjust this a little bit. Maybe use something as carpet and simply use the carpet so 3D and 2D representation stays somewhat similar. Now for the rest of surface, well, you can import the concrete. Pretty much everything over here is imported. This one over here, which is a solid base brick, you are going to use a texture. Now keep in mind that the measurement for the image, just going to leave this to your own criteria, but each of the bricks we are going to use measure 2.5 by 13 by 26. And well, for the image, we can even, for example, measure each brick or count how many bricks we got in one side. Just keep in mind that the long side is going to measure 26 and the short side, if I remember well, measures 13 centimeters. So if you want to input the real value or the real measurements for your image, you can do so over here. And now you can simply continue importing many materials from the ArchiCAD catalog. And you can also, for example, create the red tesontle external texture. For this case, we don't really need to make it completely exact. You can input a reasonable value over here, but pretty much that's it for this first part of the practical activity. So what I'm going to do is I'm going to take like 10 minutes and just make sure that I have all the required surfaces for my project. Alright, so pretty much it's done. It took me in real time like about 5 minutes simply to import the materials. And if you notice over here, we got something as this, which is a basic list we are going to use once we start creating the different constructive materials in the upcoming section. So if you notice, pretty much everything is imported. Well, the bricks are imported, all the concrete is imported. I really didn't have to move that much. Well, City Line Light Gray has a custom representation. Now this one is a little bit more important because it's going to take place once we get into the 2D documentation of the finishes for the floor. For the red tesontle, I simply used a gravel type of fill. Didn't really create a personal fill. For the solid base brick, well, if you want to create your own custom pattern, which would look something as like this, go ahead, you can do so. You can even try to use maybe a pattern that we already have within ArchiCAD, maybe brick floor laid flat. This might work, but just going to keep it simple, maybe something as dashed. And for the measurement of the image, I'm going to set it to 1560 millimeters. Okay. Now then, stucco is the carpet representation and waterproofing. Well, I'm just going to set it maybe to some type of other. Okay, background is nice for this representation. Okay. So with this, we can put an end to this first part, just the first part of this topic of the constructive attributes. Take as much time as you need. Make sure to create your own surfaces for your own project. And in the next section, now we are going to continue with the creation of the materials. And then finally, we put everything to the test with the creation of the complex profiles and also the composites. As you may have noticed, surface and fills can be linked, meaning that if you configure a surface optimally for 3D visualization effects, you can simultaneously automate its representation in 2D. Not only that, but you can also utilize a surface painter to streamline the process of assigning surfaces in your model. With the surfaces and fills ready, in the next part of the module, we will proceed with the creation of constructive materials, composites, and complex profiles. Elements and attributes that we will later use when creating the BIM model. If you have any questions, comments, or suggestions, you can reach me out through the various communication channels available on Udemy. And if you have completed this session all at once, I recommend taking a short break or rest before moving on to the next section. And having said this, I'll wait for you in the next segment.